Sorry, the UPS man just came by, knocked on the door, so I didn't know who it was. Okay, so your u was inverse tangent, and your du is going to be 1 over 1 plus x squared. Now, this becomes, so we have our du right here. So this becomes the integral of u du, which is 1/2 u squared plus c. And then we're going to substitute our u in. Okay, so this one, your u is going to be the angle of the cosine, which is going to be natural log. Your u is natural log of t. Your du is 1 over t dt. Now I have that right here with my du. So this becomes the integral of cosine of u du. And the integral of cosine is going to be sine. So this becomes sine of u plus c, and then we're going to substitute our natural log in there. Okay, this problem, your u is going to be 4 theta minus 7. Your du is going to be 4 d theta. Okay, we don't have the 4 on the outside, so we got to get rid of it. So it becomes 1/4 the integral of sine of u du. Integral of sine becomes cosine, negative cosine. And that's what we get. Okay, last one on this page. It's going to be top heavy. So when it's top heavy, you're going to have to use long division. Okay, so long division. X squared plus 1 goes right here. We get x cubed. Okay, so we say what times x squared gives you x cubed? We say x. X times x squared is x cubed. X times 1 is x. And then we have to change the signs. Okay, so I have that. Now, x squared doesn't go into a negative x evenly, so that's going to be my remainder. So this is what I'm going to actually be integrating. Now, we know that the integral of x is 1/2 x squared, but this portion right here is going to go to a natural log because it's 1 power less than it is on the bottom. So your u is x squared plus 1. Your du is 2x dx. We don't have the 2, so we got to get rid of it. Okay, so it's 1/2 the integral of du over u, which will go to a natural log. So integral of x is 1/2 x squared minus 1/2 natural log absolute value of x squared plus 1 plus c. Okay, last page. Okay, on this one, we're going to end up having to complete the square. Okay, so it's important that you remember how to complete the square with integration. So your first step is, let's factor that 2 out. X squared plus 14x plus 57. So a review of complete the square. So we're going to kick out the 57 and we're going to put a plus c. Our c is going to be b over 2 squared. So your c is 14 over 2 quantity squared. So 14 divided by 2 is 7. 7 squared is 49. So if I put in a 49 here, I have to take out a 49 here. So we get x plus 7 quantity squared. 57 minus 49 should be, what, 7? Just double checking. 8. 8. 8. Not 7, 8. Okay, so when we complete the square, to get from this term to this term, we square root the first term, keep the sign in the middle, and square root the last term. Okay, square root of 49 gives you the 7. So this is what we're integrating. And when we complete the square, it's always going to pretty much integrate to an inverse tangent. So your u is going to be x plus 7. Your du is just dx. And your a is going to be the square root of 8. Inverse tangent is 1 over a. So we got 2 over square root of 8. Inverse tangent of x plus 7 all over square root of 8 plus c. This one right here, integral of x to the 4th is 1/5 x to the 5th. Integral of pi is pi x plus c. Now remember, pi is just a number, so you got to make sure that you recognize that. Okay, so if I want to find the average value of a function, it's 1 over b minus a, so 2 minus a negative 1, times the integral from negative 1 to 2 of 1 plus x squared dx. So this is 1/3, goes in front. Integral of 1 is x. Integral of x squared is 1/3 x cubed. 2 to negative 1. Okay, so plug in a 2. So we get 2 plus 2 cubes 8. 8 divided by 3 is 8/3. Minus, plug in a negative 1, minus 1/3. Okay, so we should get, distribute your negative out, so it's 1/3. So this becomes a plus plus, so it's 3 plus, and then 8/3 plus 1/3 is 9/3, which is 3. So your average value should be 3. Okay, if I was to take a derivative of an integral, remember, we plug in the top limit everywhere there's a t, like that, and then we chain rule the top limit. So this is e to the x to the negative 6, e to the negative x to the 6th power times 3x squared. Super important that you remember how to do this, because we're going to be spending a lot of time on that in the next lesson. Okay, find the original function for the following given the initial value problem. So we're given the second derivative, okay? And I'm given these initial conditions. So we want to find the original function, okay? So we're going to integrate. The integral of this is dy dx. So we get 4/3 x cubed plus x plus c. Don't forget your plus c. Now, when we plug in our initial condition, the slope is 5. Plug in a 0. So c comes out to be equal to 5. And then we plug it back in. So dy dx is equal to 4/3 x cubed plus x plus 5. Now, to get to the original function, we're going to have to integrate again. So we get y is equal to 1/3 x to the 4th. Because when I divide by 4, 4 divided by 4 is 1. Plus 1/2 x squared plus 5x. And then we put our plus c. Now, use our initial condition is 10. Plug in zeros, get zeros. So c comes out to be equal to 10. So my answer to this problem, the original function, is going to be y is equal to 1/3 x to the 4th plus 1/2 x squared plus 5x plus 10. Last page, now we're going to do some calculator work. So it says, I want to know for what values of x is the function increasing or decreasing, okay? So this is going to be, it says decreasing in this problem. So The way we tell increasing, decreasing is by taking the first derivative and looking at our number line, just like we did. So if I take the derivative of an integral, I plug in the top limit. Everywhere there's a t, and then I chain rule it, okay? Now, we had to find our critical points. So when we found our critical points, we set it equal to 0. And then we did our number line. So our number line. So we're going to put a -3 and a 1. Okay, on our number line. Now, this term will always be positive, so it's not useful to plug anything in. So I'm going to plug in a -4. -4 plus 3 is a negative. Plug in a 0. It's positive. And plug in a 2. Should be positive. So this thing is going to be decreasing where the derivative is negative. So it's going to be decreasing from -infinity to -3. Now, next question, finding the equation of the tangent line. So to find the equation of the tangent line, we take the derivative. So f prime of x is equal to the cube root of x squared plus 7. Now I want to find the slope at x is equal to 1. So I get cube root of 8 is equal to 2. So that's my slope. Now I got to find the y value because I only have the x value. So the integral from 1 to 1 of cube root of t squared plus 7. That should have been a dt. Sorry, I messed up on that. That should be a dt right there. So the important thing to remember about this question is if I plug into an integral and I don't change the limits, my integral is 0. Okay, so that's property of integrals. So my equation of my tangent line is y minus 0 is equal to 2 times x minus 1. And if you want to distribute that out, you can. Go for it. And then this is the last question is a first FTC question. Okay, so I know I have first FTC when I'm given a derivative and 2 initial conditions. Okay, so I'm going to integrate the derivative from 2 to 5. We always write the lower limit first, and that's going to give you f of 5 minus f of 2. We're going to be doing this a lot whenever we get to velocity and acceleration stuff. Okay, so I'm going to put this in the calculator. So we're going to go to y equals, and we're going to put e to the negative x squared power, close parentheses. I'm going to do math 9 vars y1, comma x, comma 2, comma 5. And I get 0.004146. F of 5 is 1, and I'm going to solve for f of 2. Okay, so what I would do is I would add this to the other side and divide it. Add this term to the other side and then subtract the other one over. So f of 2 is going to be equal to 1 minus that answer. So I should get 0.9959. Okay. So this should get you started on integration. This is very much a review lesson. It shouldn't take you that long to do the practice problems and the homework. If you have any questions, feel free to reach out. Thanks.